a nice cross number here. Some very vague clues on the whole. However, there's a big clue is that we have to use 8 of the digits 1 to 9. So what that means is that we're not going to repeat any digits, and so we can look out for that as we go. Okay, well, the first clue to go with is definitely the multiple of 13 and of 19. They don't share any common factors, so there's not going to be that many options. 13 times 19, well, we can do 13 times 20, so 260, so we just double 13 and then times by 10, and then we can minus 13 from it to get 19 lots of 13. That's quite a nice approach, so 247. If I double that, I'm going to get 494, which by the way is out because that's got a repeated digit. If I add these two together, then I'm going to get a 1, carry the 1, 13 plus 1, 4. I'm going to get 741. That is a possibility. Or I could double the 494, which could be 908, wait, um, 988. So that one's out as well because it's a repeated digit. So one down is either 741 or 247. The next clue to look at, which is going to actually decide which one this is the fact that 3 across is a square. Now actually no square number ends in a 7 because if you look at your squares, you have like 1 and then 2 squared is 4, 9, 16, 25. Let's just write them down. 100. When you go up to 11 and then 12 and then 13, the units digit is always coming, for the square number is always coming from the units digit of the original. So these are the only numbers that can ever be the units digit of a square number. You can't get 8 either. Can't get 2, can't get 7. So we can rule out 2, 4, 7. This must be 741. Okay, so the square number must end in a 1, and as we already have seen, there's only a couple of ways we can end up with a 1 as the units digit. So we could do something like 11 squared, or 21 squared, or 31 squared. That would give me a 1 in a similar place to here. 11 squared is 121, so that doesn't work. 21 squared is, actually I know that one, 441. You can do 20 plus 1 times 20 plus 1, which gives 400 plus 40 plus 1. And then 31 squared, you can do a similar thing. It's going to be 900 plus 60 plus 1, 961. So that one's out. Okay, 31 squared is a possibility for the moment. Now, we do have to think about the ones that come from doing 9 times 9. So we could get 19 squared. 9 squared is going to be 2 digits, but 19 squared or 29 squared. 39 squared is going to be too big. So 19 squared will be 20 minus 1 times 20 minus 1. That's 400 minus 40 plus 1, 361. So that is a possibility. And 29 squared is going to be 900 minus 60 plus 1, which is going to give 841. Now we've already used a 4, so that one is out as well, which means that 3 across is either going to be 961 or 361. So we know for sure that there's going to be a 6 here. We just don't know whether we're going to be putting in 9 or 3. So at this point, you can either concentrate on the multiples of 11 that either end in a 9 or a 3, or you could think about the multiples of 9. Because a multiple of 9, the digit sum will also add to a multiple of 9. Now, there's no way this can be 1 and 1 to give a digit sum of 9 because there's a repeated digit and we've already used a 1. So the digit sum of this number 1 across is going to have to be 18. So if we do 18 minus 7, then I know the digit sum is going to be 11. And let's also pay attention to what numbers we have left. We've got 2, 3, 5, 8, and 9. Those are the only options. So let's write these arrangements down and work through them. Okay, so I'm going to consider the number being a 3 here. And then remember, I've said that we either have to use, where did I put it? Um, I either use 2 and 9 or 3 and 8. So in the situation where I've used a 3 here, I'm going to have to use 2 and 9. So it's either going to be 297 or 927. That's it. And then in the case where I use 9, I'd have to use 3 and 8. So it'd be 387 or 837. So 1 across, 2 down, 3 across, they're all satisfied. It's just where the 1 down, which is a multiple of 11, is satisfied. So I've got some options here. This is either going to be 5. I mean, I know there's lots of options, 5 or 8. So I could do 11s into 253, 11s into 283. 11s into 253, that's going to be 2, 3, 23 times. So actually this checks out. I can be pretty confident I've done it. And therefore the number that I didn't use is going to be 8, and therefore the answer is B. Let's just check the other ones to show that there's no other solutions. So 283 wouldn't work because I'd be adding 30. There's no way that 11 is going to go into that because 11 doesn't go into 30. If I go with 900, so 11's into 953. Okay, I'm going to do 88 and then it'll be remainder 7. That's not going to work. 11's into 983. We'd get 8 again and then 103. That's not going to work. Let's just keep working our way along. So 11's into 300. And what digits have I now got? I've got 5 again, or this time a 2. So 3, 5, 9. Basically, look, you get the idea. It isn't going to work out. Okay, you can check the rest. I got a little bit lucky that it worked on the first go, of course. In the answers, they look at the multiples 11 in a slightly different way. They say because um, if it ends in a 3, then it's got to be something like 11 times 23, like one of the remaining digits that's not been used, or 11 times 53 maybe. And they kind of work out that way that it might be 253. They still have to split into cases. There's no way you can avoid that. But I quite like the way I did it. So you must start with 2 down. It's just a necessity. You can work out what that is if you think about the ones that have not got repeated digits and the fact that one of them can't be the final digit of a square number. I think working on the square is a good idea at that point. That builds it up, and then you could, yeah, you have to do a combination of looking at the multiple of 9 and the multiple of 11, and then you get there. But well done on this question.